All right, so this problem, actually, 24 should be very similar to the one I did as the model problem to how to do this. So we have a level surface. So we're going to have a level surface, and we're going to have a sled. Again, you can make a sled just look like a generic box. Just it's something that is moving. So I usually just make it generic, especially a sled, because I like to put the mass inside the box if they give it to me. And this problem, they are giving the mass. They're saying it's 8.2 kilograms. So I'm going to put that right in the box. So it says a 75 Newton force is applied at an angle of 31 degrees above the horizontal. So I want to make that direction look like 31 degrees. If I start here and go in that direction, that would probably be about 45 degrees. That would be about 60 degrees. So 31 degrees is probably somewhere in there. So that is going to be my applied force in that direction. So I'm going to label it here. I'm going to have the applied force, and that's going to equal 75 newtons. I'm going to, I'll write the 0.0, I guess. All right, so there's your applied force. Now, when you do a problem like this, we want all of our forces to be in either the x direction or the y direction, the horizontal or the vertical. So I'm going to take that vector, and I'm going to break it into its components. So I'm going to go in the x direction right until I get to so that I'm directly below the end of that other arrow. And that will be my x component. So notice that I'm directly below the end of this vector right here. This vector is being replaced. We're replacing it with two vectors. So that's my x component of the force, and then the y is going to be that. So there's the y. So I want these things labeled. So that's going to be my applied force in the x direction and my applied force in the y direction. I also want to put the angle that they gave us in the problem as 31 degrees. So I'll put that there. And I'm putting this box in the corner to remind me that what I just drew was a right triangle. So I have that. Now it does say that there's a coefficient of friction. If there's a coefficient of friction and it's not zero, then there is friction. So we're going to have friction in the direction opposite to the direction of motion, because friction usually opposes motion. So we're going to have that in that direction. Now, we still have other forces in the vertical direction. If the object has mass, then it has weight. So if it has weight, then we represent that on the picture with an arrow. Now, I'm going to make this arrow that I'm drawing right now longer than this arrow here, because I know I have another arrow to draw. So the two arrows up have to equal the arrow down. So what I just drew is the weight, and I need to also draw the normal force. So the normal force is going to be a small arrow than it was when we had the force horizontal, because when we had the force horizontal, there were only two forces in the vertical direction. So this is going to be the normal force. So if I add up this arrow and this arrow, so if I put this on the end of that, the length of that should be equal to the length of that, because vertically, the object's not going to move vertically, it's only going to move horizontally. Now, we want to have the other things on the picture that were given in the problem. They're giving us the mu as 0.17, and the unknown is the acceleration, so I'll put it over there. So what I have now on the board is a complete diagram. It has all the forces are labeled. You have to label all the forces, and everything else that was given in the problem as a fact is on the picture. So that is that's called a free body diagram, what I have there. So once I have that, I want my descriptive equations that help me a lot in solving this. So if I sum up my forces in the x direction, what will that equation be? Right, FAX minus F equals MA. Remember, whenever you're writing the descriptive equation, what you're really writing down is Newton's second law. So this is the F in the formula F equals MA, but the F is the unbalanced force, so it's made up of that minus that. So that's our descriptive equation in the x direction. When we sum up the forces in the y direction, what's my equation for that? Yes. Yes, but I usually like to write the FAY first, and I'll explain that in a second. FAY plus FN, so both of those are positive because they're up, minus W, and those three are the F in the formula F equals MA. These three combined are F equals MA, but we know that there is no A in the vertical direction, so we can just set that equal to 0. Now, the reason why I line it up this way is depending on the problem, it could be more complicated depending on what the unknown is in the problem. So when A is the unknown, that's a pretty easy one. If A is the unknown or if mu is the unknown, those are the easy ones for unknowns. The hard ones are when FA is the unknown, or even when the mass or the weight is the unknown. Like if I don't know either one of these, that can be complicated. The reason why it's complicated if FA is the unknown is, look here, if I know what FA is in the angle, then I can literally get a value for FAX and FAY. But if I don't know FA, then I can't get a value for FAX or FAY. I'm going to have to write those variables in terms of FA, which means it's going to be a problem like a two-equation, two-unknown problem. Because I can replace this with FA, well, just to get ahead of myself here, I could replace this with FA cosine theta. And I can replace that with FA sine theta. So now I have FA in both of them, so instead of two different variables, I've now reduced it down to one. Because I know the angle, so I didn't, by having cosine and sine, I still just now have one. Well, friction is mu Fn, and I know mu. So if I replace friction with Fn, again, I'm going to reduce the number of unknown variables from 2 down to 1. And same thing here, that if I replace W with mg, so I could have moved this to the other side so everything was lined up, I could replace that with mg. So again, if g is a constant, so I would, and a is the unknown, so instead of having m and w as two different variables, I'll only have one variable there. So, and I'm saying that because one of the problems today that if you saw the homework, number 23, FA is the unknown. So at this point, even if FA was the unknown, the problem would look identical to this. The descriptive equations would be the same. The only thing different would be that would be where the question mark is, and I would probably know what that is. So once I know this, now I just start solving things in the order that they can be solved. So what's the first thing, what can I solve for first? I can solve for the weight. Okay, so the weight is going to be mg, and then you're going to put the m times the g. Remember I told you yesterday that as a physics problem solver, you have a responsibility to communicate your solution to the problem. So that's why when you write this, I don't just go immediately from W to plugging in values. I want to know what those things are. If I write the formula, then I know that the m is there and the g is there. So plugging in those numbers, I'm going to put in 8.2 kilograms. And acceleration due to gravity on the Earth is 9.8 meters per second squared. And what do you get when you multiply those together? 80.36? Okay, so 80.36, I'll call that 80.4 then, to 3 significant digits. So there's my weight. Now what can I solve for? Right, I can solve for FAX and FAY because I know the hypotenuse and the angle. So FAX is going to equal the hypotenuse, FA, times either the sine or the cosine. Now, don't try and memorize that. Well, let me just get what in this one, FAX is the adjacent side, so I know it's going to be FA times the cosine of theta. But don't think that every time you're solving for an x component, it's going to be cosine, because you are going to see problems where the x is the sine. It depends on the picture and what angle is given in the problem. In this one, it is cosine because that's your adjacent side, that's your opposite side. You're always using the hypotenuse, but are you going to be solving for the adjacent or the opposite? So we plug in here, and we're going to have 75 newtons times the cosine of 31 degrees. And if you solve that, what does that equal? Yes. Yeah. Right, if the angle was up here, if that's the angle you knew, and you might know, like for example, if I'm pushing on a lawnmower, maybe I know the angle up there rather than the angle down there. If the angle was here, then that would be the opposite side, and that would be the adjacent, so I would have FAX would be FA times the sine of theta. Yeah, well, usually they'll say like that notice it says 31 in this problem, 31 degrees above the horizontal. So that's the horizontal, so that's above. If I were, let's say, here, I might have, I might say that the direction, let's say if the arrow went in that direction, like if I were pushing on a lawnmower, so the arrow would end here. Then I might say that the force is the force is below the horizontal there, or I might say that the force is in a direction counterclockwise from the negative y direction. Some way of writing it where I have to reference one of the sides. So I mean, from the negative vertical direction, I'd be going counterclockwise. That would be the direction. Okay. So what's the answer for this? Okay, now I'm going to have to, at this point, I'm going to stop this and start it up because, again, it's a problem that's going to take me over 15 minutes. And if I go over 15 minutes, I won't be able to save it. So I'll stop here and I'll pick it up in